So this problem says, and if you have taken a break, good for you, let's do this problem. This problem says, suppose you put $500 in the bank and the interest rate is 7%. If you notice, what have I done till now? I have chosen interest rate of 10%. Why did I do it? Because I can do the problem in my head, and so can you. I'll have the luxury of doing it. The real world doesn't. In fact, it has 3 decimals in it or something like that. Here, we'll make it a little bit more interesting. Let's make it interesting, make the interest rate 7%. However, the interest is not coming from the 7%. If I asked you, what is 7% of $500, I hope you can do the problem in your head, and multiply the 2 and you'll get a good answer, whatever it is. It's 35, right? So, however, what's complicating things is how much will you have at the end of 10 years? So let's go back to basics, and I'm going to force you to do this. And the reason is, if you don't, I'm going to do it. Whether you want to do it or not is obviously your choice. I'm going to be very timeline oriented, especially in the beginning of the class. So what's the time? This is 0, right? How many periods? Again, for convenience, 10 years. What's the other element you know in a problem? I know that I can put P here as 500. You can think of it as P, PV, short. So the question now asking is, what the heck is going on here? Again, please remember, we have no risk. So I've gone from 2 years to 10 years, and you know, a lot can happen, and a lot has happened in the recent past. So I don't mean to belittle what has happened. I just think that uncertainty cuts both ways, and we have seen a lot of bad effects of a crisis. But I'm going to ignore all uncertainty for the time being so that we understand the effect of time. Now, this is not easy. It's very simple to understand conceptually, because what would you do? Just carry it forward 1 year at a time, and if we had all the time in the world and the only problem to solve, we could do it and 10 weeks would be over. So, but we want to write the formula out. I want to take 1 plus r, which is the factor, which in this case is, and what do I want to do? How many times is this happening? I know it's happening over 10 years. So here's the problem. I'm raising it to the power of 10. And remember, every time you go forward, the factor is 1 plus r. So after this 1 year, it would be times 1.07, 1.07 square, and so on. This thing, by the way, if you can do it in your head, there's something seriously wrong with you. You need to grow up and do more interesting things in life. But there are people who can do this in their head, and I think there's something, you're spending your time on the wrong thing. Just think through. If you have understood what's going on, this is where you ask yourself, do I get a calculator? Or do I get Excel? And what I'm going to do is, you have notes on using either one. The calculator has to be financial, but not in this problem necessarily, because you can raise things to the power 10 and so on. But this is the kind of algebra that you have to be comfortable with. Therefore, I'm throwing in the algebra before actually solving the problem. But to solve the problem, we'll have to do what? We'll have to go to Excel. And I'll show you a very simple way of doing Excel. Okay, so let's see. If you can see what I'm doing there, I'm going to the tab on top, the space on top that says fx, and that is where the functions reside. So if you haven't got the finance functions, you can always get them from Excel. It's not a big deal. But the thing I'd like you to know is this. It's very intuitive. So what are the key elements you need to know to solve this problem? I think the key elements you need to know is you're solving a future value problem. So the first thing you do is you put in something that you don't know. You don't put in something that you already know, because the Excel will look back at it and you will say, you already know the answer, why the heck are you asking me? So it's future value I don't know. And as soon as I press future value, guess what pops up? What pops up right there is the first thing you need to know, which is the rate. And the rate is the interest rate. As I said, symbols are something that you need to familiarize yourself with. And another thing about Excel, which many calculators differ on, is in Excel you have to write the rate exactly as it is. So it is 0.07. Many calculators would allow you to just write 7, but in Excel if you write 7, that means you're assuming the interest rate is humongous, right? So what's the next element it asks for? It says NPER. The N is the operative word, PER stands for periods. So in this case, I believe we have to type 10, because there was interest rate was 7, the number of years passed is 10, and then there is a button called, or there is a symbol called PMT. For now, ignore it. And the reason I'm asking you to ignore it is it doesn't enter our problem. That's the next element we'll get into next week. And PMT stands basically for something called payment. So when do payments happen, say on a loan? They happen regularly. Right now we are just looking at $1 transfer time travel over time. So I'll put a 0 there, because if you don't put a 0, it won't know what's going on. And then I put PV, and I know PV. It's I who has put the money in the bank, so I better know how much it is, right? So I put in there, and then I press return. Now what you'll notice is it's showing up in red. You're noticing $983 and some cents. By the way, I'm not interested in cents here, right? So I'm not even interested in the answer so much. I'm interested in you understanding why I used Excel. And the reason I used Excel is because the human mind cannot calculate something raised to power 10 very easily. And in fact, there's a whole video created and research done on this, that humans are very good with linear stuff, and humans are not very good with nonlinear stuff. So that's why maybe sometimes finance looks like a challenge. But if you break it up into bite-sized pieces and recognize why you're using Excel, Excel doesn't control you. You control Excel, right? I hope that's pretty obvious. So if you've seen Matrix, it's a very different world, and we are not there yet. So don't let Matrix enter your mind thinking that Excel is solving your problems. One day it will, but not for now at least. So what is 983? $983 is the value of $500. How much? How many years from now? 10. But there has to be another element in answering this problem, and that is the interest rate. So the interest rate is 7%, and the world remains sane for the next 10 years. And I get the 7% a year, assuming no risk right now. I'll get $983 in the bank. But clearly, if the interest rate were lower, I would have less. If the interest rate was higher, I would have more. The real cool dynamic is the interaction between time and the interest rate. So the interest rate is a per year number, in this case 7%. But the real cool interaction, which we call compounding, is between the 7% interest and the number of years, 10. And the more years that happen, and we'll see a problem soon, the more the dynamic becomes very powerful. So here you've almost doubled your money in 10 years at an interest rate of 7. That wouldn't happen at a lower, would happen faster at a higher rate. So I hope this is clear to you. Now one last comment, and I said I'm not going to spend too much time on Excel, but I have to kind of satisfy your curiosity. Why is the number in red? Why is it negative? Now think about it. This is actually a pretty cool thing. So Excel has been set up to make you realize that if you put in a 500 plus today, it has to be negative in the future. So think about it. Who is getting the $500 today? You're giving it up, But who's getting it? The bank is getting it. And what will they have to do 10 years from now if they are getting it? Remember, I put 500 positive in the PV. They'll have to give up 983. So the lesson from Excel is pretty cool, and that is you can't get something for nothing. There's no such thing as a free lunch. So if the bank, you give 500 and are willing to give another 983 to the bank, then you are the sucker, not the bank, and bank will be pretty happy. In fact, probably will feel like doing business with you, and you'll go out of business and the bank will be in business forever. So just wanted to give you a sense of that. I'm going to come back to this in a second because I want you to recognize that doing these problems on Excel is simply because you can calculate things faster. So let me do some examples, by the way, and I want to emphasize one thing. A lot of these examples that I am using in this class, I don't even remember how I thought of them. I mean, a lot of my colleagues at Michigan have helped me become a good teacher, if I'm a good teacher at all. A lot of the things we talk about, a lot of the examples we use, a lot of the notes we use with each other. And to be honest, when you read literature out there, a lot of these numbers have real world meaning. So let's go to the next problem and show you the power of compounding. What are the future values of investing $100 at 10% versus 5% for 100 years? Why am I doing this? I'm doing this simply to give you actually real world context. So which kind of person, and I promise I won't talk about risk, but I'm by implication talking about it. Because if there's no risk, how many interest rates would there be? One, and it would be the same. Because risk largely is responsible for different interest rates. But for the time being, let's assume, for whatever reason, you have two opportunities, 5% or 10%. In the real world, what would this mirror? The 5% is kind of closer to a bond, where the difference between a bond and the stock is it's less risky. The 10% is kind of closer to what the US stock market, say, has given. It's given more over the last, say, 80 years. So I'm just anchoring them in kind of real world problems, but keeping the interest rate simple so that it's not 4.265. It'll just take up time, and you can do more real world problems in your personal investing. But here's a cool question. Suppose your grandfather or great-grandfather had invested $100 100 years ago in the stock market versus a bond. That's the kind of context. How much money would you have today? Clearly, you cannot do this problem easily, right, in your head. So, but I'm going back to the problem we just had, and I'm going to just modify it. So how much was the interest rate possible? So let's start off with, instead of 7%, the new problem has either 5 or 10. So let's start with 5. What is n? It's very obvious that n was 10 in my previous problem, but now it's 100. And 0 is PMT again, but how much money am I putting in? In the previous problem, I had put in 500, and now I'm putting 100, right? So if my fingers are going all over the place and I punch the wrong number, we'll all deal with it, right? I mean, I'm teaching you one-on-one. I feel like you are listening there. Believe it or not, I feel like I can see you. But anyway, before you think I'm really strange, let's move on. Okay, so you have about $13,000 plus a little bit. What do? If your great-granddad had put $100 in kind of a bond and it had grown to, and of course, let's assume it's a government long-term bond and the government is still there and so on. So remember this number, 13,150. But the question asked you, how much could it be at 10%? And if you asked a lay person on the street, who's probably smarter than me, but if you just ask them, because they haven't done finance. So suppose I change the interest rate from 5 to 10. What do you think would happen. And I think what that person will think is think linearly. They'll try to say, oh, okay, maybe it'll double. So remember what was the answer the first time, about 13,000. So I think I got this everything right here, 100 years, $100, that hasn't changed. Look at the answer. And the answer is about 1.3 or 1.4 million dollars. So what does that tell you? That it's a mind-bogglingly dramatic change. And the culprit there is what? Simple. Who's the culprit? Compounding. Or who's the beneficiary? Compounding. So I want you to just think about this for a second, and I'll go back to the problem and show it to you so that you feel comfortable with the question I have asked you. What are the future values of investing 100 at 10% versus 5%? So what did we see? 30,000, 1.3 million, if I'm reading it right. Huge difference. So what's going on? Let me ask you this. Suppose there was no compounding, right? Suppose there was no compounding, which means what? Interest will be treated like it's different. Interest cannot earn interest. The only thing that can earn interest is the original $100. Let me ask you, with 5%, how much will you have after 100 years? And you should be able to answer that question very easily. And the reason is very simple. Simple interest rate is additive. It's linear. We are very good at it. So let's take, will the $100 still be there? Sure. But every year, how much will I be getting? 5% of $100 is $5. After 100 years of $5, how much is it? 500. So you see how simple it is? That you have $500, $5 at a time for 100 years plus the original 600. But what was our answer? Our answer was 13,000, right? So where's the difference coming from? Compounding, you see? it's really unbelievable. You can't visualize this stuff. But let's go to the the second problem. So now I increase the interest from 5 to 10%. How much am I getting every year on the $100? Well, twice as much. I was getting $5 first, now I'm getting $10. What is $10 times 100? 100 years. 1,000. So how much do I have? I have $100 plus another $1,000. Sounds pretty reasonable. But what was the answer at 10%? More than $1 million. So you see what's happening? Two things are happening. Compounding is very tough to understand, but it's real. It's been happening. People have made money with risk, obviously. However, what's even more complicated is a comparison with compounding between 5 and 10 becomes a total nightmare. It's very difficult to comprehend because it just blows in your face. So if you want to think about a really cool example, actually provided in, I teach executives with a couple of my colleagues, and this is borrowed from their example, and it's a real world scenario. So read this for a second. Peter Minuet, if I'm saying that right, by the way, I don't speak French, so if I've screwed up his name, pardon me. Everybody screws up my name, so no big deal. Peter Minuet bought the Manhattan Island from Native Americans for $24 in 1626, right? Suppose the Native Americans had decided not to, had decided to sell the land and then taken the money of $24 and put it as a quote-unquote financial investment at about 6%. Why am I choosing 6%? Because it's neither too high, it's neither too low, though we don't know what interest rates are likely to be in the future given what's happening now. But let's stick with 6%, I think, just as an example. How much would the Native Americans have in the bank today? So this is your problem to solve, and it's not an easy one. So let's try and see how would we do this